Okay, so we now have the continuation of our discussion on normal distribution, particularly finding the area under the normal curve. So please take hold of the table that I gave you because that will serve as our reference in finding the area under the normal curve. So maybe we have an example. We have finding the area of 0.6. Okay, first you have to illustrate. Okay, so it would appear like, okay. So where that is 0, 1, 2, 3, 4. We have negative 1, negative 2, negative 3, negative 4. So where it's 0.6 approximately here. So there is 0.6. And then draw a line and then shade the required region. Okay, the shaded region is going to be the area that we are looking at. So that's the area of 0.06. Okay, so in your table, 0.06 is 0.6, I should say, sorry. 0.6 is 0.2258. And notice the whole area at the left is covered or shaded. So that's going to be Z left. As I was saying, as we were discussing during our first session about the properties, half of it is 0.5 or 50%. So that's 0.500. Okay, so just add the values. So we have there 8527. Okay, so the area of 0.6 is 0.7258. Okay, so that's our first example. Second example, say we have 2.13. Okay, say 2.13. Again, we're going to illustrate. Okay, so that's our normal curve. And so we have 0, 1, 2, 3. So 2.30, okay, negative 1, negative 2, negative 3. So 2.13 is somewhere here. Okay, and then shade all of it. So the shaded region is the area being required. So maybe we have to consider again. What is 2.13 in your Z table? We have 0.48, sorry, 4834. 0.4834. And again, the whole of the left is shaded. So Z to the left is equal to 0.500. And then you have to add. So we have 43890. So the area of 2.13 is 0.9834. What about if we're going to consider the area between 1 and 2? So there's going to be another solution for this. So you have to draw the normal curve. There is 0, there is 1, there is 2, and 3. Negative 1, negative 2, negative 3. But we are just looking for the area between 1 and 2. So between 1 and 2. So that's the shaded region. Very small, right? Okay, so in getting the area between 1 and 2, you have to consider first the greater Z value and then subtract the lower Z value. So get the value of 2, which is equal to 0.4772 minus the value of Z, which is equal to 1, which is 0.3413. And just subtract. And what's going to be the difference? We have 0.1759. 1759. Okay? So that's the area between 1 and 2. So this is how we go about finding the area under the normal curve using our Z table. Okay, again, stand by for our next discussion. That's going to be Z scores.